So we're going to actually create 3.5-inch holes and 4.5-inch holes apart. Our best bet would be to draw a circle at the corner. The top ones are going to be 3.5, so D, enter, 3.5. We're going to move it down from the quadrant. If you can't grab the quadrant, you go to your O snap, you turn on your quadrant. You're going to take it from a quadrant, move it down, and then we need an actual space of material so it looks nice. We'll move it down 1 inch. Now you can do mathematically and figure out that we need to move it this far and then plus an inch, which would be 2.75. But instead we're just going to move it over from the quadrant to the wall, and from the wall we'll go 1 inch across. Now an easy way, if you don't feel like doing the math and figuring out how far apart these are, what you can do is if you go to your quadrant, let's see if I can grab it. Alright, that won't let me do. So what we're going to do is draw a line from the quadrant to the wall, or across, doesn't matter, it's just a construction line. From there, you take the circle, you go copy it from the wall to the quadrant, to the quadrant, quadrant, and so forth until you get to the end. We have extra space. We might have to do something different here to actually fill up that space and not waste it. Or we could move them to be in the middle. We'll decide. So next one, we take all these, we copy it down, and we copy it from the quadrant to the other quadrant, and we move it half the circle, and then we also move it half an inch, and that will get us in between them. Now we're missing one, that's okay, we can just add it in by taking this circle here, copying it from this center to this center. Usually, okay, that doesn't fit, that's okay, it's just a reference for now, we'll work it with. Now usually what people would use is an array for this, but since we don't know the actual distance apart, that's why I'm doing it this way. Once you have this one, all you have to do is select all these, and you can just mirror it over in the center of these circles, like so. Now you can take all of these, mirror it over from this, and you can do that again to get the rest. Of course, there's going to be more than we need, and they're going to be in different spots. That's okay. So first we're going to fix this by taking out all the bottom ones, the 2 rows, because we're going to actually add bigger size types. We might even do some more. This is really up to you guys to choose from how many you guys want, big ones and how many small ones. It's all preference at this point, but I'm just showing you how you would actually create them to make them fit into your plywood. These I probably have to delete, so I'm just going to delete them now. It looks like it's all set up, except of course the bottom. I'm going to draw a circle from the bottom, diameter 4.5. Go move it from a quadrant up and move it 1 inch up. This space looks kind of small, but it just might work. So I'm going to leave it for now. I'm going to use a mirror command to mirror it over. Yeah, it's not working. So I might have to just remove this layer and work with this one. I'm going to copy them over from one to the next, like so. Okay, of course if I delete this one, I can move these over. There you go. Move it over 2 inches. So there's that piece. I got this area that I have to figure out how to fill it out. Let's see if I can actually fit these circles. Yeah, they won't work. So I might just have to delete these again and add a separate row of big holes. Okay, that actually looks pretty decent. I might just leave it as it is, but I would like to at least have the same thickness. or maybe bigger thickness between the bigger ones, because the bigger ones are heavier. So I'm going to move it 1.5 inches apart, and I have something like that. This one will be the best thing to do with this one to make it solid later on will probably be press pull. Be so much easier than anything else. So we'll use press pull for this later on. But if I moved it into my front view, I can actually make a copy of this like so. That would be my cabinet type. That's one cabinet. I'm going to make a copy of this over. I should not see it. So I have another one I have to work on, which is on this side of 36, and I'm going to make a copy of this again, and I'm going to stretch it over to make it a 48-inch. But once I made this 48, I have to make sure I change all these to it too. So I'm going to put this over for a second. I have this, so this should be actually all enlarged by 12 inches since it's a since it's a 48-inch cabinet, like so. Alright, I'm going to pause and work from here. Alright, I have to adjust a few things. We have to, this should be not a section view of this piece, it should be the full out width, which is the length of from here to here, or from here to here, the inside length, which is 34.5 by 2 inches. So we do a circle, rectangle, D for diameter, 34.5 by 2. Sorry about that, that was my mistake. But that's that piece that goes here, here, and here. And there's 3 of them. I'll put in the dimensions for it, like so. Alright, that's, and we have to actually double these things because there's 2 cabinets that are 36 inches wide, and they're basically designed the same exact way. So instead of 3, it's going to be 6. Instead of 2, it's going to be 4. Instead of 2 over here, it's going to be 4 here. Instead of 1, it's going to be 2 for the bottom of the cabinet. And the next thing is, for this piece, there's going to be actually 2 pieces. One on the front view, one inside to hold the bottle. So this exact design is going to be 2. Okay? And we're going to make a copy of this supporting pieces, the 3 supporting pieces, over to our 48-inch type. And we're just going to stretch it to be 48 inches for a 48-inch cabinet by 12 inches. Because it was 36, to make it 48, we just stretch it by 12. So I have the 3 pieces, or actually there's more pieces, but the 3 types for my 48, and I have the 3 types for my 36. This actual piece is the same for all types, no matter if it's 48 or 36. So we have to make sure that this, instead of saying 4, it says 6. So we have 6 of these, 6 of these, 4 of these, 2 of these, 2 of these, 6. This makes, now this should be 3 of these, and we're going to copy that over. There should be 2 of these. If you can't find out if you can't figure out the numbers, it's okay. I'll go back to them, or I'll talk to you in person and show you where I got these numbers from. This one? This is the actual, these 3 pieces here, because we should be measuring them. Since it's plywood, it should be drawn out this way instead of 8. Yeah, that's a mistake I should have copied in the beginning. So that's that piece, and there's 6 of them because we have 2 cabinets, 3 each, so that equals 6. Our next cabinet, I will pretty much show you guys the design. It's gonna be a door cabinet that holds our glasses. So this is how you would design a door cabinet with handles. These are just the handles. I didn't put them in the right place, but I'm just showing a demo of how it would look. On our final cabinet, we will have a drawer on top that is 6 inches apart, 6 inches wide, 2 separate pieces right there, and the rest can be a door, or if you guys wish, you can make them more drawers. But I think most of your utensils, that's all you need to actually create it. So something like that. The drawers won't be that deep because we're gonna put a sink here. So one of these drawers will be shallow, one will be super deep, or actually both if we put an ice area. But we'll go over that. I'm just drawing it out as a reference. This one is actually perfectly shown. Each door you'd have to draw in. So you would actually draw a rectangle, make a cup, move it over, and that's actually a door. Now, since this one is one door is exactly the same as this second door, you just can double it, and you will have all the ones you need. So if you do 2 times and dimension it out, it will cover this door here. But that is creating another issue because the door doesn't know how to stop. Usually a door swings out and there's actual little piece that goes right in the middle, and it's usually about 2 inches wide, which we'll use this sizing, but I'll show you that in a little bit. So we basically have the door. We have 2 because there's one on one side, one on the other side. We need a supporting material in the middle so that the door, if there's a gap, you won't see inside, and to stop the door from swinging all the way back, because right now it has nothing stopping it from swinging back because it's an inside door, except the hinges on. But the hinges usually are set up that way that they swing all the way. So we just have to get a 2-piece that goes the distance of this right here, which is 30.5. I think we had one somewhere. Oh, we can just use this one here, 2 by 34.5. But we just have to modify it using Control Copy, Control Paste, and it's a little big, 4 inches too long. So we're just going to do a stretch command. Stretch is pretty good. If you go to stretch over here, or you can go to your modify stretch command. What stretch does is if you select like this, whatever is inside the box, a full segmented line, like the one you see over here, like this little piece, it will just move. The rest, if it's only half of it, will stretch. So if I'm taking this, this piece right here will just move, the rest will stretch. So I'll show you. See, that just moves, the other two lines stretch. We're stretching it back by 4. Now we got our piece. We can draw it in as dashed lines for reference, but I think we all understand where it's going, hopefully. But the next step we actually will need to do is we'll actually have to draw in a drawer, at least one inside. To do that, to actually draw in a drawer, we make them smaller than the actual area inside, because it will be hard to adjust it if we have adjusting pins to move it up and down. So we try to give it some clearance, because wood is never the same size. These panels could be, you know, after years deform, and your shelf, I say drawer a couple of times, I meant shelf the whole time, sorry about that. The shelf should be a little bit smaller than that, giving it little gaps in the ends in case the wood expands and contracts based on, you know, temperatures and all this other stuff. That's the problem with wood. It's all nominal numbers, and you gotta make sure that you put in clearances for wood a lot larger than steel, because steel, you don't have that issue. So for the shelf, I would make it 34 1/4, so that gives me a 1/4 inch an eighth here and an eighth here of free play. So to do that, we will do a rectangle command, click a point, D for diameter, it's going to be 34.25, and we didn't decide what depth we're doing. Right now it's 22. Usually depth wise we always give it some space in the beginning, so drawer, the actual shelf starts from around here to the end. So we'll make that, we'll give it 2 inches, so we'll make it 20. So that's going to be one shelf. If you want to make additional, add shelves, just put a quantity for this. But right now we're just going to make it only one. I'm just going to dimension it like so, and give it a quantity. You can put the quantities in the middle if you want, as long as you know how many you need. That is what you should be showing. That is actually our second cabinet, the one that goes here. Our third cabinet is the 48-inch cabinet, and this cabinet's going to be a little bit different because it has drawers. It will have a shelf, it has doors, and the drawers, actually one will be deeper, the other one won't, because we have a sink and it's going to interfere with the sink. Drawers are a lot more difficult because there's actually 5 parts to one. You got the front, back, bottom, side, and left side, right side. So that's why it's difficult, and that's why those cabinets usually cost more. So if you are looking for a least expensive idea, you may consider making only 2 or one full one, but we're making 2 because one side is going to be deeper, the other one's not as deep. So we'll go ahead and start with making the doors. We can use a rectangle to trace over the inside of one, which is the exact same size as the other, so we just gotta move it over. You gotta put 2 in here because those are our doors, like so. We got to do a shelf. Again, we can do the same design, or we can just copy this to our next cabinet, and we go to modify to stretch it. Again, whatever is inside will just move. So this piece right here is just moving, the rest is stretching, and we stretch it by 12 because we know our cabinet is 12 inches longer. So it also gives us a 1/4 inch free play. We have that, we have that. Next part is actually our drawers. That's the worst part. If I look into the other drawing, you can see this one's a little bit designed differently. It's notched, so one goes into the other. You can actually, if you want, use this drawing as it is and copy it and use it for this drawing, or we can design it a completely different way. I'm going to design it completely different so you guys get a feel of how I would do it. But you can see that the actual drawer face is a lot smaller, larger than the actual drawer. The drawer gives it a lot more gap. It's for material wise, plus you don't need it to be that high, so that's why they do it. They actually added a support material for it, and if you go to the front view, which I don't think I have a front view here. No, I don't. Oh, here. You can see there is a space, and that space will have the hangers, slides to for your drawers to slide in and slide out. I think I have some more. Yeah, that shows you the actual size of the face. It overextends a little bit. This is the type of one that's on the exterior of your cabinet, not inside. We're actually designing the inside type. So this one's the exterior type, and the hinges are not outside. Ours is going to be a little bit different because ours is inside, not the outside. It's a pretty cool looking design. See, he probably used right here. It's probably a 3D object. No, actually, that might not be. Oh, I should not have done that. I just shift 3D rotate. But anyways, you could have used if it was a. Yeah, I think I just crashed my computer. Yeah, save your work, guys. Alright, great. Okay, so lesson of how to get back your stuff that you lost. Part A. Remember where you saved it. Where did I save it? I think that's, yeah. Right, that's a recovery one that when I said please save, that may have the most up to date. But before I do that, I usually like to double check my backup file. Let's see if I have a backup file. That's my videos. There's my original. Actually, I'm going to open this one. I'm going to find out where my original saved backup, because some of your backups are saved with it. Alright, I think I didn't lose much. Drawing manager. Hey, yeah. Alright, sweet. I didn't lose that much, but still. I need to go back and show you guys how to rescue a lost file. If I go to save as, it's going to tell me the desktop. Alright, we go to tools, options, files, and there should be a save. I'm getting open save. Create a copy of the save, yeah. Where is? Can anybody see the save part? I'm gonna pause this because it's alright, found it. It's right here. Autosave. And that usually tells you where it's saved to. This is a good thing to remember. It's in my options. I go to files, autosave file location. Mine's saving in C drive. So if I go to my computer, I go to the C drive. Next place, users. So I scroll down to users. Sebastian. App data. Am I missing it? It's not here because I probably have it hidden. So you go to folder options, view, show hidden files. There it is. Alright, you get in there, you go to the next one, local, then you go to temp, and we'll see if it's in here. It should be the exact name of what your current file is called. So bar recover. Well, the one's gonna be called. It's gonna be bar something. So I'll go back into that file. Type in B for bar. Except it's a different form, so I'm going to go. All right, bar BAK. So there's my backup. And the last time it saved was at 7:16. Yeah. Guess that's not the most updated one. But I can still try it. I'll copy it. It'll go on my desktop. And when you do this, you paste it. And what you want to do is change that BAK, the ending, .BAK, into a DWG. And it's going to ask you yes, and just say yes, you do want to change it. It's actually now a regular AutoCAD file. Yeah, that was what I was doing at 7:16 today. So, I mean, at least I didn't lose too much. Yeah, I did. But sometimes my autosave must be off. It must be saved every 30 minutes instead. or something. I don't know. There has to be a reason why it didn't save it every 15 minutes like a standard default setup should be. But that's really useful because a lot of times your computers will crash and you will probably lose most of your data, and that's how you can go back to it, as long as it's saved at least once. Alright, so we have this piece, that's the door. Again, for that door we need to create a supporting part in the middle. But before we do that, we need to create a supporting top part for the drawers. I'm just going to go over here. I will demonstrate by drawing it out. It's going to be a rectangle diameter D 46.5 by, you guessed it, 2. I'm going to move it over. It's going to be in here. This should be dashed because it's inside. So now we can figure out exactly, I'll put in my dimension toolbar. We can find out exactly what size piece I need to add to it. So from here to here is what I need to add, a 2-inch support material. So I'm going to do rectangle again, D enter, 23.5 by 2. Dimension that out, and that's my next piece that's going to go here, and then I can take this piece that I created, is my piece right here that I showed you before. Again, dimension that out, like so. So I have that piece, I have the actual, this is the shelf, this is the door, there's 2 of them, there's 1 shelf, I could add more shelves, but that's good enough. And the next step we actually have to do is design our drawers. I'm going to pause it for now. So what we need to do now is the drawer. The drawer will make a rectangle of the face. So that's actually 1 piece. Oops. I'm gonna move it over. Oh jeez, come on. There we go. Move it over. And there's actually 2 drawer faces exactly the same size. So I have to make sure that once I dimension it, I put 2 times. Now, to make it correct and not to worry about anything else, I will add this here, this 2 piece in here. Okay, and then I will add a space that I will need for my slides, drawer slides, about like 1 inch. 1 inch here. And I have to put in the ending this, because drawers also have a problem that they have a little gap, so we have to make sure that we have that piece in here, which is 1 inch this way, 1 inch this way. It looks complicated, but I'm just doing this to figure out what my working area is, and this is my working area. So whatever I design cannot be bigger than this. So here's an example. I'll go back. Take this. I'm going to move it to exactly the drawer face. So this is my working area. I'm going to move this over, and I'm going to design the actual drawer bottom and sides. The bottom is usually the full size, so we're going to do 0.75. The side walls are connected like so. So I'm going to remove that and draw a line closing this all up. So now if I moved it back, it would fit right in without a problem, and it would not hit anything else in the case. Now I might as well just to play it safe, because wood of course expands and gets smaller when depending on temperature, I will make this a little bit smaller again. You can go to modify, stretch this down about 25 or a quarter inch, and I'm going to stretch from the bottom up 0.25. So now I can dimension it out, but you can't manufacture it this way because you don't know what the length of the piece is. Because we all know what the thickness is, 3/4. That's what we decided to do for everything. So each piece will be 4 inches and depends on the depth of the drawer. But come to think about it, we also have to do the back. You know, you have the front frame, then we have to create the back of here. The back is going to be the actual size of this. So just make a square around your whole area, move it down. That is your back piece. The thing about the back piece is that there's going to be 2 of them. There's actually be one in the front and one in the back. If I switch, I don't have the other drawing open. Now let me open up my other drawing. Oh, I didn't save it. Give me a second, I'm going to switch computer. So now if I do the math, there should be 4 of these because there's one in the front, one in the back, and there's 2 drawers, so there's 4. And for this, we have to change this into actual panels, and we have to decide our top depth size. One is, again, I said it's going to be deeper, the other one's going to be less deep. We will make one. I gotta figure out the math wise now. Pause for a second. Alright, one of them is going to be 8 inches deep, the other one's going to be 18 inches deep. So just remember that. I'll draw it out though. So these 3 parts have to be in 2 depths. D enter 10 inches deep by 4 inch high. That's these 2 pieces. And the bottom base is going to be D enter 21 enter and again 10 inches deep. Okay. Now the good part is if I draw up once, and let's say one of my drawers is actually deeper than the other, I can just stretch them to fit the new requirements. So I can do actually the math too. I need 1 of these and 2 of these. These are the sides. This is the bottom. I have the back. I have the front. I have the back and front twice, and I have the actual drawer face. I have 1 of these. Okay. Now I just gotta copy these over, and I will stretch them because I'm gonna make it deeper to 18 inches. So I'm gonna go 8 inches deeper. That is the whole design of the drawers. That's if you get the numbers wrong, that's okay. If you get the sizes wrong, that's okay. Because we're going to design it in 3D, and if it doesn't work, you'll go back to your 2D and fix it. But once you have all this done in 2D, you can go ahead and save it. So you go to File, you can Save button, and what we're going to do next is go to File, Save As, and we'll change that. Add additional one and call it bar3D. That way you have one file that says bar and the other one says bar3D. Okay. Oops.